For this question here, we have a system of linear equations. And there's a couple different options of what we could do here. I'm going to go through each of the, in my opinion, three primary approaches. Because they are both in standard form, and because all of the answer options are actual ordered pairs instead of stating something like no solution or infinitely many, I would go ahead and actually use my program solve systems. So when we look at the program number 4, solve systems, we could just type in the coefficients. Notice this coefficient of x is 2. The coefficient of y here is a negative 1. Make sure you use the negative key down here instead of the minus, otherwise you'll get an error. And then the constant is 12. For the bottom equation, you have the coefficients of 3, negative 7. Again, make sure you use the negative key, and 7. So once we type those in, we get our ordered pair as 7, 2, making the correct answer C. And in my opinion, making this the quickest approach. Now you could also use Desmos, which I would say is a close runner-up here. And the Desmos calculator is in the upper right of our software as well as in Blue Book, the platform you'll be using for the digital SAT. We'll go ahead and click here. You may need to zoom back out. I'm using my touch screen, but you could obviously press Control minus if you're using an actual non-touchscreen device. And we'll go ahead and type these in. If you had any other equations from a previous problem, you'd click the gear icon and delete all. I didn't have anything, but that's good to know. And also, you could use their own keypad that's down here, but I'm a big fan of just using my own. So I'm going to just type these in with my own keypad. So we'll go ahead and type in 2x minus y. Now, a nice thing here, I didn't have to worry about the difference between minus and negative, which is nice with Desmos. It's the same thing. And then I'll press enter. I'll type in 3x minus 7y equals 7. So you're doing pretty much just as much typing. I would say less typing here because you're just typing the coefficients. And also with Desmos, I obviously need to go ahead and look at the graph and then click to find the ordered pair, whereas on the program, it just gives it to you. And we could see that the ordered pair is 7, 2. So we get the exact same answer, both really nice approaches. Now, in case you're curious how to do it by hand, which is really, I would only do this in your math class, so it's just good to know, but definitely not a good approach in my opinion when you're trying to save time and avoid errors. Let's go ahead and look at the back side of page 33 from your math reference document, which is side 2. And notice the difference between substitution and elimination. Substitution is really convenient when either a variable is already by itself, like in this case, this bottom equation, or if it can easily be isolated, which really means if the coefficient is 1 or negative 1. However, if they're in standard form or you don't have any coefficients of 1, which could produce fractions, elimination is definitely a better approach. So in this case, they're both in standard form. So what I would do is try to eliminate either x or y. To figure out which one to eliminate, let's go ahead and look for the least common multiple between the x's and the y's. So the least common multiple between the x's is 6. With the y's, it's 7. So 6 is smaller, so I'm going to go ahead and... Actually, I think it's easier to deal with the y because this is negative 7. I just need to make this top one positive 7 so that they cancel out. Whereas if I try to eliminate the x's, I really need to multiply the top one by 3 and the bottom equation by 2 and make one of them negative. Doesn't matter which one, top or bottom. So I'd rather just multiply one equation instead of 2. So I'll eliminate y's instead. So if I multiply the top equation by negative 7, I have negative 14x plus 7y equals negative. You could obviously use your calculator. I like to do a multiplication shortcut. 7 times 10 is 70. 7 times 2 is 14. 70 and 14 is 84. And then I still have the same bottom equation here. And then I could just go ahead and add these. Notice the y's eliminate by design. It's called elimination. I get negative 11x. And then I get negative, obviously you can use your calculator, but you get negative 77. And then we get for x 7. And then of the options, the only one that has x is 7 is C. However, if you needed to, if let's say you got this narrowed down to 2 options, you would then plug the x back into either equation. I'm going to plug it back into the first one. I think that one looks maybe a little bit more straightforward, but they're both pretty similar. And then we get 14 minus y equals 12. Subtract the 14 to the other side. We get negative y equals negative 2. Divide by negative 1. And we get y equals positive 2. So any of those three approaches work. However, in my opinion, the best one was using the graphing calculator program solve systems, then Desmos, then doing it by hand.